Hi, my name is John Krochmalny, and I've been developing these video presentations to orient PLC learners to automation technology now being used in industrial, commercial, and residential applications. This presentation will be exploring the PLC inputs and how they relate to the PLC control technology. There will be three learning outcomes associated with this presentation. Number one, explain the different voltages involved with PLC inputs. Number two, explain the need for optical couplers in PLC technology. And number three, identify the positions of diagnostic LEDs associated with PLC inputs. This slide features three distinct voltages involved in PLC technology. Two 120-volt AC supplies and one 20-volt DC offered from the power supply. Notice that the power supply is provided with 120 volts. The power supply steps down this voltage down to 20 volts DC. This 20-volt DC provides the power to all PLC modules. The Micrologic's PLC input section is located at the top of the unit. The Allen Bradley SLC 500 has its input located in a separate module and can be replaced or repositioned in the rack. All PLC inputs will have diagnostic LEDs assisting technicians in their analysis of PLC operation. These LEDs are low voltage lamps that are either in an illuminated state or an off state. This slide is a graphical representation of a typical PLC input section. Notice the diagnostic LEDs located at the top of this input module, as well as the PLC processor located to the right of the module. The PLC power supply is located directly under the processor. A separate 120-volt AC supply is being offered to switch number S1, thermostat T1, contact C1, and a limit switch LS1. These switches are wired in series with certain terminals marked from 0, 1, 2, up to 3. How these inputs are wired to the PLC terminals are important and related to the PLC programming and its use of PLC Programmable Logic Controller ladder logic programming languages. In this graphic, each switch is wired into the input screw terminal according to terminal number. Since the terminations are on the PLC input module, the PLC processor will assign the letter I as an indicator of the screw terminal and it being associated with an input. Notice that switch S1 is wired to terminal 0, and the PLC processor uses its address as I:0. I stands for an input, and 0 stands for the terminal it is wired to. Following this protocol, thermostat T1 is wired to terminal 1 and has reference to I:1. Notice that the open set of contacts labeled C-1 is wired to PLC input terminal 2 and has reference to I:2. The limit switch LS1 is wired to PLC input screw terminal number 3 and has reference to I:3. The operation of the input switches determine if the applied voltage registers on the screw terminal. In this example, switch S1 is open. 120 volts AC supplying the switch does not pass through and onto the input termination screw 0. Notice the diagnostic LEDs located at the top of the input module. The LED marked as 0 is off, indicating that there is an absence of voltage occurring on that input screw terminal. When switch S1 is closed, 120 volts AC will be passed through and onto the input screw terminal marked 0. Notice the diagnostic LEDs at the top of the module, and particularly LED 0. This LED is now illuminated. The PLC processor actively looks at these screw terminals for the presence of voltage AC and makes a record of their condition. Because the processors operate on 20 volts DC, There's a technical problem trying to read the condition of a 120 volt AC situation. For this reason, PLC inputs have optical couplers that are designed to communicate voltages back to the processor and keep the higher 120 volt AC power away from 20 volt DC circuits. In this example, S1 is open, 0 volts AC is recorded on the screw terminal input. The PLC processor records this condition as 0 in its registry and under input 0. Also notice that the corresponding diagnostic LEDs for this screw terminal is off. With switch S1 closing, 120 volts AC is present on screw terminal 0. The optical coupler sees 120 volts AC, but sends a message back to the PLC processor with a 20 volt DC signal. The processor registers this condition with the placement of a 1 in the proper registry. Notice also the diagnostic LEDs associated with this PLC screw terminal input has now been illuminated. On this slide, we can see the conditions of input screw terminal 0 and 2. Notice the change of registry in the PLC processor. Also notice the illumination of the associated diagnostic LEDs. PLC input modules could also use analog sensors, providing some conditional value. Notice that the input module is not a two-state, but an analog device. This analog device is being supplied with 20 volt DC from the Programmable Logic Controllers power supply, and also 24 volt DC from a secondary power supply. An analog sensor, in this case a thermal sensor operating with a 4 to 20 milliamp signal, is able to measure temperatures of between 50 and 100 degrees Fahrenheit. The PLC processor converts the 4 to 20 milliamp signal into a binary coded decimal value for controller purposes. In this graphic, we can see the conversion of temperature to milliamp values. If the sensor senses 50 degrees Fahrenheit, a 4 milliamp signal is sent to the processor. If 100 degrees Fahrenheit is sensed, a 20 milliamp signal is sent to the PLC processor. Notice also that if a 75 degree Fahrenheit condition is sensed, the value being sent to the PLC processor will be 12 milliamps. Notice that using this matrix and configuration, any temperature value can be identified and sent to the PLC processor as long as it operates within this temperature span of between 50 and 100 degrees Fahrenheit. As previously mentioned, the milliamp signal going back to the PLC processor allows the processor to convert the milliamp value to a binary coded decimal value, otherwise known as BCD. This new BCD will permit the processor to know and control the sensed environment. It is important to understand that although PLCs come in various sizes and complexities, they all have the same operations. Utilizing this example, all PLCs will have input sections and are used to sample controlled conditions. If the input PLC section looked different, they will all have certain diagnostic LEDs. Technicians can refer to these diagnostic LEDs for input device status.